Hello friends, welcome to my YouTube channel AZ Cloud Training. Today we are going to see how to build an elastic web hosting with AWS. So you must have used web hosting for hosting your websites, maybe WordPress sites, maybe OS Commerce sites, maybe your blogs. So we are just going to see how to use AWS for doing this. Um, what is the cost involved? We are going to touch upon that as well. And basically, the video is going to be about how to put these different pieces together. And before that, what are the pieces that are needed? So let's take a deeper dive. Okay, website is more like a three-tier application. So the first tier in this case is the client tier where you're accessing the website using workstations, personal computers, mobile devices, IoT devices. And when you type say azcloudtraining.com, what happens is the request is sent to the server where basically a web or application server receives it. So the web and application server is the second tier in this architecture, and the layer basically, or most of the times, hosts the application logic. This web application server then interacts with the database server. So database server is the server uh, which hosts the database, and again, the database is where all the data resides. So with that as a preface, let's see what are we going to do, what are we going to build in today's exercise. So in today's exercise, we are going to build a setup like this. So we are going to have a region in which we are going to have two availability zones. In first availability zone, we are going to have a public subnet and then a private subnet. And then in the second availability zone, we are going to have another private subnet. Um, to understand what is public subnet and private subnet and VPC, I have a dedicated video for that. Please take a look at that link. In the public subnet, we are going to have our web server because again, it is supposed to be communicating with the internet. So it's going to sit in the public subnet. In the private subnet, we are going to have our RDS or relational database. We're going to use MySQL for that. And then the private subnet, which hosts the database, is going to talk to the public subnet with the help of NAT instance, which is Network Address Translation instance. And the little cloud on the other side is us, which who are going to access the setup via a browser. Okay, so that's at a very high level. Again, why availability zone 1 and 2 and how the two database instances are going to talk to each other. It's basically a topic for a detailed video later on. But for now, let us understand this is basically a multi-availability zone database setup where two instances of the database are going to be set up, and basically it is for the high availability kind of setup. I'll touch upon the higher availability and fault tolerance kind of topics in separate videos. But for now, let's take those buzzwords and go with it, and let us dive quickly into the demonstration. Okay, so I'm here in the AWS Management Console. In my previous video, I have talked about the VPC and the default VPCs. So I'm not going to create the default VPCs. In fact, I have deleted the default VPCs because I wanted to demonstrate how to create the VPCs. So we have a clean slate here. So I'm just going to click on, VPC. Again, there is an option of creating a VPC right from here. But guess what? AWS offers us a much easier option, which is basically the launch VPC wizard. Let us click it. Okay, so here basically we get multiple options. The first one is VPC with single public subnet. So imagine a situation where you don't have to have like a complex structure like, public and private subnet. You can very well host your database as well as a web server in the same public subnet. And that's most of the times what happens with the, shared web hosting. Um, your web application server as well as the database server are in the same network, and one can actually access your database if they know the credentials and the pathway to your database, then they can very well do that. But in this particular case, we're kind of keeping that in a private subnet so that it is not accessible directly via internet. It will be accessible for the web server, but through internal setup. Okay, so we are going to basically select this, visit, which is basically VPC with public and private subnet. Again, there are two additional, configurations of visit setups that are given, which the one is with the hardware VPN access, and the other one is basically again with no public subnet and a hardware VPN, and we are not going to use that. So I'm going to stick to VPC with public and private subnet. Okay, so let me select it. And now in this particular screen, you can see, well, AWS really gives us everything kind of, pre-made. We just have to tweak a little bit. So what I'm going to do is I'm going to say, well, 10.0.0.0/16 offers 65,000 IP addresses, and I'm okay with that. So I'm just going to name my VPC as say AZ Cloud VPC. Okay, so I'm going to have my public subnet, which is going to be 10.0.0.0/24, which is going to offer me 251 IP addresses, and that's cool with me because I'm not really hosting a lot of components which are going to need a lot of IP addresses. Mine is going to be a very simplistic setup, so this is cool. Availability zone, no preference. I can give a preference here. I'm going to select, say, to A. Now, public subnet is going to be named as public subnet. Well, that's cool, but I am just going to name it as AZ Cloud Public Subnet, just to make it more, naming convention compliant. The second is going to be the private subnets IPv4 CIDR block, which is going to be 10.0.1.0/24, and I'm going to have like 251 IP address with that CIDR block as well. Well, that's cool as well. So I'm going to use the same availability zone as the public subnet just to make sure that I align with the setup I have in mind. With that, I'm just going to name this private subnet as AZ Cloud Private Subnet 1. And why 1? Because I'm also going to set up the subnet 2, which is going to be in the next step. So the next block over here says use a Elastic IP allocation ID and NAT gateway. I'm not going to use a NAT gateway because it's actually a costlier piece of hardware. For our purpose, we can just go ahead and use the NAT instance. So NAT instance is basically a hosted and managed service. So it basically, as the name suggests, it's an instance. So it basically creates another EC2. A T2 Nano is good enough. It's actually cheaper than the NAT gateway. So I'm going to select that and make that happen. So let's say, so I don't have to change anything here. Um, and I'm going to say, yes, go ahead and create the VPC. It's going to take a few seconds. So this is the best part of AWS. You basically have all the services kind of instantly available. You can actually create and delete if you don't like or if it doesn't work and then start afresh. Most of the times it just takes a few seconds or a couple of minutes to really set up the services. Okay. With that, we have our VPC ready, which is and it is available. We have our subnets too, which is private subnet 1 and public subnet, and the CIDR block and all the details that the way we configured. So before we go any further, what we are going to do is create another subnet, select the VPC, and this time I'm going to select the 2B, and it gives me a choice of selecting a CIDR block, and I'm going to say 10.0.2.0/24, and with that I'm just going to say create. Well, it just created it for us, and we have both the private subnets ready and the public subnet ready as well. The next thing what we are going to do is just quickly check what are the route tables and whether we have the specific route table set up for us. So this one uses route table 0FF ending with 9. Just going to check whether my private subnet one also uses the same, and it does. Public subnet uses a different, so which is fine because it has to talk to the internet, so it is okay to do so. Then what we are going to do is we are going to create a subnet group. So what I'm going to do is just go back to my AWS console and go to my RDS and quickly select okay, so here I'm going to quickly select subnet groups and just going to create a quick subnet group. I'm going to call it as AZ Cloud DB subnet group. And again, why we need a subnet group? Again, the name suggests subnet group is going to be a, compilation of all the subnets that are available in the VPC. And when we create the RDS, it's actually going to use this subnet group to launch the multi-AZ setup. So it will basically create one database instance in the availability zone, which is, and the subnet, which is actually defined in 2A, and the other subnet is going to be used for the which is going to be in the 2B. It will be used for the second instance of the database. Okay, so subnet group, and then I'm going to choose the VPC. Now here I have to choose the two availability zones, and then it's going to give me all the subnets that I have created. And the last but not the least is to hit create, and it's quickly going to create the DB subnet group for us. Again, I'm going to take you back to the VPC setup, and here, okay, so here basically I'm going to take you back to the VPC just to make sure that we have everything set up now. You can see here that internet gateway was created as well when we created the public subnet, so that the public subnet can talk to the internet. Okay. All right. So the next step is to create the security group. Now we're going to create two security groups. There is one already created for us by as the default. Along with that, we are going to create another one. So first is basically the AZ Cloud public subnet security group. So I'm just going to call this as public security subnet security group. And the inbound rules for that are going to be give me the SSH traffic, and it's going to be coming from anywhere. And again, this is not the safest. You might want to add just your own IP address. For the sake of demonstration, I'm going to create as 000. Again, I'm going to delete this right after recording, so I'm not going to basically expose this setup to any risk as such. So I'm cool for now. So I'm going to add another rule, and this time it's going to be the HTTP, again coming from anywhere. Now this you can keep it as 000 because you want your application to be available or accessible from anywhere. So HTTP rule can be set up to, coming from any IP, but from SSH or RDP you might want to add specific IP addresses. Okay. Outbound rules, again, it says all traffic can go to 000, which is fine for now because your application has to access the internet or give your data back to internet. So I'm going to say create the security group. Now note we created this public security group. What we are going to do is create a private security group now. So this time I'm going to say AZ Cloud DB Security Group, or ST short for short. And again, I'm going to say Database Security Group. Now, the inbound rule for this is going to be, well, we are going to only talk to the MySQL database. So I'm going to say MySQL and Aurora. And look what happened here. It identified the port on which the RDS typically talks. It's 3306. So it's only accepting that. And then I'm going to say custom IP, and in the list I'm going to select the security group that we just created. So the idea here is, the private subnet is going to accept the traffic coming in only from the security, public security group and nowhere else. So That the idea of having this internal messaging or internal communication between just these two subnets is basically being enforced with this setup over here. All right, so the outbound rule is still going to be all traffic goes to 000, and which is still fine for me for now. So I'm going to say go ahead and create the security group. Okay, so we have our security groups, we have our subnets, we have our VPC, and we have our NAT gateway. Now, what's next? We are supposed to launch our EC2 instance and the RDS. So let's go ahead and take the RDS part out. So I'm clicking on RDS. For this demonstration purpose, we are going to use the MySQL database. You can use any, depending on the purpose of the application that you're building. Again, the choices are many as offered by AWS. We have Amazon Aurora, we have MySQL, MariaDB, Postgre, Oracle, and SQL Server. Most of the times, MySQL, MariaDB, and Postgre are kind of open source, so we have you can build cheaper solutions with it. Oracle and Microsoft SQL Server have their own use cases, and Aurora, I'm going to create a separate video, and we are going to dive deeper into it. Again, it is very scalable and highly elastic kind of solution that is offered by Amazon. So we are going to take a deeper dive into Amazon Aurora in a separate video. For now, I'm just going to select MySQL and let's see what we have here. Okay, so it is asking me, what do you want to do with this? So I'm just going to say use the free tier to develop the new application and test. Let's see what are the different, you know, deployments that are available for me. So again, here I can name my database instance. I'm going to keep it as database-1. Again, I'm going to call my master username as admin. I'm going to say, uh, give me a password. I'm going to keep it very simple for now. Again, this is not to risk the setup in any way, just to make the demonstration easy. Now, DB instance, the burstable class, there are other two choices, but for free tier, the other classes are not available. Again, I'm going to use the burstable class, which is basically going to give me the elastic power that I needed. SSD, the storage type can be kept as SSD. Again, there are several other choices. We can have provisioned IOPS, but again, for now, to be, just for the demonstration purpose, or if you're just starting your application, and want to keep your cost low and you're just trying to test your application, then you can go with general SSD. Provision IOPS is for a busier website where you have established traffic and established user base and a lot of transactions that are happening, and you don't want to drop any of the transactions while being written to the database. Then you would go for the provision IOPS. So do you want to enable the storage auto scaling? So yes, this is a great feature that the dynamic scaling is being offered by AWS, and I'm going to select yes. Now, notice that multi-AZ deployment is not available, and the multi-AZ or multi-availability zone is the exactly the setup that we thought we would have. For the demonstration purpose, I'm going to just go with the free tier. What happens is if I select the production template, then the multi-AZ will be available for us. It's not going to give us any benefit when we are, going, we are selecting the multi-AZ for the demonstration purpose, because we are not going to do any testing with the multi-AZ. So I am going to go ahead and use my free tier so that I can keep my costs low for now. And then I'm just going to go ahead and go to the next connectivity option. It's so okay. So here basically I'm going to expand the additional connectivity, and this is where basically you have to give the subnet group, and that's why we created it in our earlier step. Public access, I'm going to select no, because we don't want your database to be available to the public. It has to be only accessible from the public subnet, but not by the open worldwide internet. So Security group. Now here is a good choice we have. We can create a new security group, but we have already created one. So instead of default, I'm going to use the DB security group. Now remember, this is the security group where we enable the access coming in only from the public security group. So our security is kind of set. Availability zone, do we have a choice? Yeah, so we get two choices. As per our diagram, we are going to keep it into A, and since we are going to have only single availability zone setup, we have to set it up in the 2A. That way, our public subnet and the private subnet is in the same availability zone. Okay, so um, estimated monthly cost, you can see here that it is actually free for us, so we are good. But what happens is, let me go back and change it to production and then select, say, multi-AZ, which is actually here, and see the cost. So again, you can very well see what is the cost involved. Now you can see here that we have provision IOPS, which is actually charged at $100, and the DB instance is charged $100. Again, this is monthly. So what we can do is we can actually tweak some numbers here. So we can use general purpose SSD instead of provisioned SSB, and we can keep our storage say 10 GB because we don't need that bigger storage for now. And my the provision IOPS cost, which was $100, is gone, and the storage cost also got reduced. Now, if I have to change the database instance to a lower database instance, I'm going to choose the burstable class, and guess what happens? The $100 is now gone down to $12. And if I again change my, uh, you know, turn off the multi-AZ, then it will basically get rid of the multi-AZ cost as well. So let me show you that. So do not create a standby. And guess what happens? You're only charged for the instance that is being, um, you know, and then guess what happens? You are only being charged for the instance that you're creating and the storage that you want. Okay. So it is as easy. I mean, as you saw, the cost could be $100 or $300 or just $13 or free, depending on your use case. You can actually control the cost. Let's stick to the free tier and no multi-AZ. Again, it'll just automatically scale back everything and give us the standard setup. All right, so go ahead and create the database here. Wonderful. I don't want to save this for now, but guess what? The database is being created now. So while the database is being created, let's go back to our AWS console and create our EC2 machine. Now this is going to be an interesting part. Please pay attention. So now we are going to launch an instance. Again, we get so many choices. I'm going to say Amazon Linux Type 2. This is more recent, so I'm going to use this one. Okay. Again, for the T2 Micro, which is the free tier, I'm just going to use that. Say next, well, we get some choices over here, and we have to choose this wisely. So network, yeah, AZ Cloud VPC is the VPC that I want to use, but where do you want to keep it? I'm going to actually keep it in the public subnet because again, this is what we thought, we are creating the web server now, so it has to be in the public subnet. So that's exactly where we are trying to keep it now. Then auto assign public IP. Right now it is disabled, but guess what? We want it enabled because uh, this has to have a public IP address so that we can connect to it. If it is disabled, then you will not have a DNS name and you will not be able to connect to it. So make sure that you enable this and to make it a successful setup when you want to really test it out. Okay, so placement group, we can just keep everything else as standard. We're not going to change anything. Again, primary IP is auto assign. We can actually make it like a um, we can actually have like a fixed IP, but right now, just to keep the cost low, we are just going to keep these very standard setup. It's giving me 8 gig of storage. I can keep it all the way to 30 gigs. For now, I'm just going to use because I'm not going to create like or store a lot of files or a lot of data on my server. So 8 gig is more than enough for me. Again, I can encrypt it. I always prefer to do that because it doesn't add any overhead, but definitely adds security. So that's good. And then we are going to call this as, say, my key is name, and then this is my AZ Cloud web server. Okay, so then configure the security group. Well, select an existing security group because we have already taken care of all these security groups. We're going to use the public subnet, and guess what? It shows me all the, inbound rules and outbound rules that we have selected, right? So this is cool. So let's go ahead and review and launch. Again, it basically tells well, it's your security group is open to the world because SSH was set to 000 and HTTP is set to 000 as well. And HTTP, we said HTTP is fine, but SSH has to be limited to a particular IP address, and that's the one is all about. Now let's go ahead and launch it. So it's asking me, do you have the key pair with you? I have already downloaded the key pair, so I have it, and then I'm going to select launch instances. Okay, this is perfect. So we have it. Now, what happens is the key pair that usually comes is the key pair that you can actually use it to connect with Windows instances. For Linux instances, we have to convert that key pair to PPK or a type which is which will be or to the or to or a type which can be accessed by PuTTY, which is going to be our client that we are going to use it to connect to the Linux machine. So in here, basically, we have to load the uh, you know .pem file. We open it, we load it, and guess what? It basically creates the um, you know the ppk file for us. So what we have to do is we have to use the parameter ssh-1 or RSA and then save the private key. Again, it gives a warning without a passphrase to protect it. Yes, I'm just going to go ahead and use that way. And then we are going to store it as azcloud.ppk. I have already saved it, so that's why it was showing up here. And I'm not going to overwrite. I just wanted to, show you the steps how it is done. All right, okay. So we have our instance, and I'm pretty sure our database is ready as well. Let's see if it is not, if it is or if it is not. So let's go back to our RDS. Let's go to databases, and guess what? It is ready and it is being backed up. Well, fine. So I can go ahead and at least start working on my web server. Right now, what we have is just the EC2 instance, but we have to actually convert that into a web server. So we have to install some applications on it. Let's see. All right, so I'm just going to use the PuTTY. Again, we have to give a host name over here, right? So what we have to do is we have to go back here and go to our EC2 machine and instances. And what we are going to do is we are going to click on our web server. And this is the public DNS that we were looking for. Again, I'm going to say EC2 user @ this. And when we are connecting with PuTTY, we have to go to SSH and authentication tab and provide the PPK file, which we created before. And then we say open, and basically it will give us some warning about the security certificate. We are going to say yes, and voila, we got connected to our machine. Now, we have a set of commands that we want to run for this. For now, we're just going to say sudo yum update -y. So this is basically just updating the kernel, and right now looks like everything is updated, and we don't need anything to be updated. I have the set of commands already copied. So what's happening here is it's basically installing the web server and the PHP and MySQL plugin, which basically is going to make the PHP talk to MySQL. And guess what? Um, it does not have the package. So I have to actually abort it and then say exit. Let's go. Okay, so let's go back here. AWS. I'm going to say give me another EC2 launch instance, and this time I'm going to select the I'm going to select another one. Free tier is still available for me. I'm just going to select the same steps. uh, Public subnet. So the what I'm trying to do here is trying to find a image where you have your PHP version available. Otherwise, what will happen is when you're creating the script, it will not work the way you intend it to. So name, I'm going to say AZ Cloud Web Server. It has to be unique, so I'm going to say AMI 1. That's what it is. So security group, again, select the existing one, and I'm going to launch it. Well, yeah, launch me. I have it. So okay, all right. Okay, so it is created now. So what I'm going to do is again do the same step. I'm going to go to EC2. The instance must be ready by now. So let us, well, it is being created, so which is fine. I'm just going to copy the things that I need and just going to keep it handy. Okay, so it's running now. So again, I'm going to go to the putty, same step, EC2 user, at, then the DNS name, EC2 user, at, and then the DNS name, and then SSH. So here I'm going to select the AZ Cloud PPK, open, yes, voila, I'm in. And this time it is Linux AMI. No package needed for security, two packages available. It says run update, so I'm going to do sudo yum update. Okay, yes. Okay, so it updated the packages that it had to. Then again, I'm going to, okay, so that's not the right command. So I'm going to take it from here, copy it, and then paste it here. Okay, so it found it, it is installing, all good. So right now what we have is we have our PHP, we have our web server. So web server is now set up and it's working. Let us just quickly check the PHP version. Guess what? It is 7.2. So it is set up. Now we are going to check config HTTPD on. Okay, it's fine. Now what we are doing here is, we are trying to set up some security here. So we are going to add a group called www, and then we are going to add our user in the group, and then we are going to exit and connect again so that it is going to take in effect. So let's see. So putty again, um, ec2 dash user at the rate where that's our ID, DNS name for the server, again SSH, auth, and then the key, open, we are inside again, and let's take a quick look at the groups. Yeah, EC2 is part of the www group. Now the next step is to change some, you know, the permissions to various files. So var/var www is the directory where you keep your files. So I'm just going to run these commands, which are basically going to take care of the file system and the permissions assigned to it. Now the next step is basically to go to that actual directory, and let's take a list of what we have. So HTML is the folder where we are going to keep our HTML files or PHP application files. Right now I'm just going to create a new folder, and in here we are going to create a dbconfig file. So we're going to say dbconfig.inc, and then we are going to nano it dbconfig.inc. So this file is now created. I'm going to copy the sum of, okay, so here basically before we do anything, we have to update this. Now, what this file has is, name of the DB server, username, password, and database. We have to change this string to the database uh, endpoint that the database offers us. So what we have to do is go back to RDS and pick up the, okay, so from here we have okay, so we are here in our database, and this is the endpoint that we need to connect to our database. So I'm going to use it over here. Okay, and then again, that's the password I used when I created it. Is it a security threat because I'm sharing it on the in my YouTube video? No, because I'm going to delete the database and all the setup right after the video. So it's not going to be there. So don't even try to connect. It's not gonna work. Just coming back here, adding that, and I'm going to come out of my file. Yes, write it and then exit. Okay. You can use VI editor if you want, if you prefer so. It's totally up to you. So now my file is in the INC folder. So I'm going to my HTML folder, and I'm going to again create a sample page. So I'm going to call it as mypage.php, and then I'm going to nano it, uh, mypage.php. And I have some code ready. So what it is trying to do here is, it is including the configuration file, and then it has a combination of HTML code and PHP. Again, the little prerequisites is you probably know the PHP language already, and you know how it works. So what it is trying to do here is it is using a constructor or function of MySQL connect, and it's connecting the to the database. If it fails, then it gives us the error message, and then the database name that it connects to, and it does some business logic. Again, what we are trying to do is we are just going to have a simple form with the employee name and address. We are going to add that to the database, and then going to read it from the database, and then show it on the page. So let us copy the whole code and take it to the um, page, and then I'm going to say Control O, yes, and Control X. So right now, if you see, my file is available. So ls minus lrt is going to give us the um, you know uh, the ls minus lrt is going to give us the security that it has, and it looks like it is read, write, read, write, read. I'm going to just make it like change mode 777 for now, just to avoid any kind of security issues. Well, let's ls minus lrt is, so we have all the permissions on it. Okay, so with that, I think we have our setup available. So what we can do is we have to go back to our AWS. EC2, and the web server that we have launched this application, a very simple one, and that's the one. So I'm going to click on it, and that's my, DNS slash mypage.php. Okay, so it says error creating the table, which is fine for now. Let's see what happens and say add data, error adding the employee data. But guess what? It is actually able to connect to the database because we are not getting any database related errors. So again, at this point of time, we can um, choose to debug at the database level, but for the sake of demonstration, I think we can stop here.